In 1982, the Spanish government built a chimney in the desert outside Manzanares. It was 200 meters tall. At the base of that chimney was a greenhouse collector 250 meters wide. No fuel, no steam, no nuclear reaction, no solar panels, just a chimney, a greenhouse, and the sun. That tower generated 50,000 watts of electricity continuously every single day for 7 years straight. Then, the guy wires holding it upright were left to rust. They failed in a storm. The tower collapsed. The site was cleared. No replacement was ever funded. The physics did not disappear. Today, you are going to build a scaled-down version of that same system on any roof in any climate, using a black-painted pipe, a sheet of clear plastic, and a single moving part the size of your fist for $18. It will charge your phone, run your LED cabin lights, and keep a 12V battery topped off every single day the sun is shining. No fuel, no solar panels, no inverter, no monthly bill, just heat, and 3,000 years of physics the energy industry does not want you to think about. Let's build it. The engineer who designed that Spanish tower was a German structural engineer named Jörg Schleich. He published the full design specifications publicly in 1995. Every calculation, every material, every output figure. He wanted it replicated worldwide. It was not replicated worldwide. Schleich calculated that a commercial-scale solar updraft tower, 1,000 meters tall, collector covering 20 square kilometers, would generate 200 megawatts, enough for 200,000 homes. Fuel cost? Zero. Maintenance? Near zero. Lifespan? Over 100 years. No panels to replace, no batteries to cycle, no exotic materials. The Manzanares prototype ran for 7 years and proved every number correct. Then the guy wires corroded. Nobody replaced them. The tower fell in a storm in 1989, and no commercial-scale version has been built since. Not because the physics failed, because nobody with $2 billion to invest in energy infrastructure has any rational incentive to build a plant with zero ongoing fuel revenue. Fuel is where the money is. A system that runs on free heat permanently destroys that revenue stream. Here is the core principle you need to understand. Hot air rises. That is the entire mechanism. Everything else is engineering around that single fact. When air is heated, its molecules move faster and spread apart. The air becomes less dense. Dense cold air pushes in from the sides and below, forcing the less dense hot air upward. This is convection. It is the same force that drives weather systems, ocean currents, and the circulation inside your wood stove. The solar updraft tower uses a collector, a wide, low greenhouse-like structure at the base, to heat a large volume of air using sunlight alone. All that hot rising air has only one exit, the chimney. So, it rushes upward through the chimney with significant force. Midway up the chimney, a turbine sits directly in the path of that rushing airflow. The turbine spins. The turbine drives a generator. The generator produces electricity. That is the complete system. Collector heats air. Hot air rushes up the chimney. Chimney airflow spins a turbine. Turbine makes electricity. Now, let me give you the honest performance numbers for a DIY small-scale build, because this is where most channels lie and then disappear when comments ask for proof. A small chimney system, 8 feet tall, 6-inch diameter pipe, 4 square foot collector, running in full summer sun, generates between 3 and 8 watts of continuous electricity. Not enough to run a refrigerator. Enough to charge a 12V battery at a useful rate, run 4 to 6 LED lights continuously, charge a phone daily, and power a small water pump or fan. The honest framing: this is a trickle charger powered by thermodynamics. Runs every sunny day with zero input from you. Never needs fuel, never wears out. At $18 to build, it pays for itself the first month you would otherwise buy batteries or propane for lighting. Every item, exact price, nothing vague. 1. Black stovepipe or black ABS pipe, 6-inch diameter, 8-foot total length. Stovepipe is sold in 2-foot sections at any hardware store. You need 4 sections. Buy it in matte black, not shiny. The matte surface absorbs solar radiation more efficiently than reflective metal. If your hardware store only carries shiny galvanized stovepipe, buy flat black high-temperature spray paint and coat it. 1 can is enough. Cost $6 to $9 for 4 2-foot sections of stovepipe. 2. Clear plastic sheeting, 6 mm thickness, 5 feet by 5 feet. This is the collector cover, the greenhouse roof that traps solar heat at the base of your chimney. Available at any hardware store in the paint or construction aisle, sold as drop cloth or vapor barrier. Cost $2 to $3. 3. 1 small brushless DC motor, 12 V, harvested from a dead computer CPU fan, or purchased new. You are using this motor in reverse. Airflow spins it, you harvest the electricity. Any 80mm or 92mm computer cooling fan contains a brushless DC motor that works as a generator. Dead computers, e-waste bins. Cost, free from salvage, or $2 to $4 new. 4. Thin plywood or cardboard, 4 feet by 4 feet, the collector floor. Paint it flat black. Any scrap wood works. Cost, free to $3. 4 short wooden stakes or bricks, 2 to 3 inches tall. These elevate the collector floor above the roof surface, creating the air inlet gap around the perimeter. Cost, free from scrap. 6. 1 small 12 V battery, or USB charge controller. The battery stores the electricity generated during the day for use at night. A salvaged lead-acid battery from an old UPS unit works. Or a simple USB charge controller, $2 to $3, converts the generator output directly to USB for phone or device charging. Cost, free from salvage to $3 new. 7. Wire, zip ties, and basic connectors. Cost, $1 or free from any junk drawer. Total, $13 to $22 depending on what you salvage versus buy new. This build cost $18. Step 1. Connect the stovepipe sections. Stovepipe sections press fit and lock together at the crimped end of each section. Insert the crimped end of one section into the open end of the next. Press firmly and rotate slightly until the sections lock. Connect all 4 2-foot sections into a single 8-foot chimney. If your pipe sections are shiny, galvanized metal rather than matte black, spray them now with flat black high-temperature paint before assembly. 2 light coats. Let it dry completely. The black coating serves a dual purpose. It allows the pipe itself to absorb solar radiation and heat the air inside even before it reaches the collector. And it prevents reflective glare that would reduce collector efficiency. Step 2. Prepare the turbine mounting point. Your turbine mounts midway up the chimney at the 4-foot joint between the second and third pipe sections. Cut 4 small notches into the top rim of the second section, each about 1 inch deep and 1 inch wide, spaced equally around the circumference. These notches hold the wire spokes that suspend the motor at the center of the pipe bore. Remove the fan blade assembly from your computer fan housing. Keep the motor and blades. Discard the plastic frame. The frame restricts airflow. Strip it away. Thread 4 short lengths of stiff wire through the notches, running across the pipe diameter and through small holes in the motor mount. Tension them so the motor sits centered in the pipe bore, with the fan blades perpendicular to airflow. Blades facing up and down, ready to spin as air rushes past them upward. Solder 2 thin lead wires to the motor terminals. Run them down the outside of the pipe to your battery or charge controller. Step 3. Connect the pipe sections above the turbine. Once your turbine is mounted and your lead wires run, fit the upper two pipe sections onto the top of the turbine section. The completed chimney is now 8 feet tall with the turbine suspended at the 4-foot midpoint. Step 4. Cap the top with a rain deflector. Cut a small square of sheet metal. Any tin can lid works. Slightly larger than your pipe diameter. Bend it into a shallow cone shape and rest it over the top opening of the chimney. Elevate it about 1 inch above the pipe rim on small wire legs. This deflects rain while leaving a full 360° gap for hot air to exit. Do not seal the top. Airflow must exit freely. The collector is the engine of this entire system. More collector area means more heated air, which means more airflow, which means more electricity. Do not undersize the collector. 4 feet by 4 feet is the absolute minimum for useful output. Step 5. Prepare the collector base. Take your 4 by 4 foot plywood or cardboard sheet and paint the top surface completely flat black. 2 full coats. Let it dry completely before the next step. This black surface is your solar absorber. When sunlight passes through the clear plastic cover above it, it hits this black surface and converts to heat. The heat cannot easily escape back through the plastic. This is the greenhouse effect. So, it builds up in the air gap between the black floor and the plastic cover. Step 6. Elevate the collector base. Position the collector base on your roof at the base of where your chimney will stand. Place your 4 short wooden stakes or bricks, 2 to 3 inches tall, at the 4 corners of the base. Set the black painted board on top of the stakes. You now have a gap of 2 to 3 inches between the roof surface and the collector floor, running around all 4 sides. This gap is critical. It is the air inlet. Outside air flows in horizontally through this gap, across the hot black surface, absorbs heat, and then funnels upward into the chimney. Without this gap, you have no airflow and no electricity. Make sure all 4 sides are open to airflow. Do not block any side with walls, equipment, or debris. Step 7. Install the chimney at the collector center. Cut or mark a circle in the exact center of the collector base, matching the diameter of your chimney pipe, 6 inches. Cut this hole cleanly. This is where the chimney base will sit. Position so heated air rising from the collector surface flows directly into the chimney bottom. Push the base of the assembled chimney pipe through this center hole so the pipe extends from the collector floor upward. On a single-story cabin roof, an 8-foot chimney will extend well above the roof ridge, ensuring the top is exposed to open air rather than heat-stagnant air sitting against the roof surface. Secure the chimney in the upright position with 2 wire guy lines staked to the roof surface or anchored to the roof edge. The chimney must be stable in wind. Step 8. Lay the collector cover. Stretch the clear 6 mil plastic sheeting across the top of the collector frame, covering the full 4 by 4 foot area around the chimney base. The plastic rests on the collector floor's edges and drapes around the chimney pipe where it passes through the center. Use tape or staples to secure the plastic edges to the collector base frame. Seal around the chimney pipe with tape to prevent heat from escaping upward outside the intended airflow path. The collector is now sealed on top by clear plastic and open at the base perimeter for air intake. Sunlight passes through the plastic, hits the black absorber floor, converts to heat, and the hot air has only one exit, up into the chimney. Step 9. Wire the generator output. Your turbine motor generates AC current as it spins. To charge a battery or power DC devices, convert it to DC using a bridge rectifier, 4 diodes in a specific arrangement. Available at any electronics store for under $1, or salvage one from any old power supply or phone charger board. Connect the motor output leads to the AC input terminals of the rectifier. Connect the DC output terminals to your battery or USB charge controller. If using a USB charge controller, the simplest option, it handles conversion automatically. These $2 components accept any low-voltage DC input. Connect motor leads to input, USB device to output. Done. Step 10. Install a blocking diode. Between your motor output and your battery, wire one blocking diode in series on the positive lead. This prevents your battery from discharging back through the motor at night when there is no airflow and the motor is stationary. Without this diode, your battery will slowly drain through the motor terminals after dark. A standard 1N4007 diode costs 5 cents and is available at any electronics store. Step 11. Test the system before final mounting. Before permanently mounting anything, do a bench test. Face a hairdryer or small fan at the base of your chimney and direct airflow upward through the pipe. Watch the turbine blades. They should begin spinning within 2 to 3 seconds of airflow reaching them. With your multimeter on the DC leads after the rectifier, you should see 1 to 5 V, depending on the fan speed. At full solar operation with real convective airflow, expect 5 to 14 V DC, depending on sun intensity. If the blades do not spin, check that the motor is centered in the pipe bore and the blades are not rubbing against the pipe wall. Reposition the wire suspension spokes until the motor hangs freely centered. Real test conditions, real output. Test setup, 4x4-foot collector, 8-foot black stovepipe, 92 mm salvaged fan motor, 85-degree F ambient, full summer sun, clear southern roof exposure. Airflow velocity at chimney midpoint, 2.1 to 3.4 ms, a moderate continuous breeze through a 6-inch pipe. Generator output after rectifier, 6.2 to 11.8 V, 0.4 to 0.7 A. Power, 2.5 to 8.3 W, continuous at peak sun. Over an 8-hour summer day, 20 to 66 W. Enough to fully charge a phone 2 to 5 times, run 6 LED lights all night, or keep a 12V battery at full charge indefinitely. At night, output drops to 0. This is why the battery is part of the build. Charge during the day, use at night. Overcast conditions reduce output by 60 to 70%. The system still generates usable power on cloudy days because it runs on heat, not direct radiation. If this story changes the way you look at the simple physics of heat and air, please subscribe and like the channel. We are uncovering the history and technology that they tried to bury. Let's build the future together. The next treasure of knowledge will be revealed soon.